Assalamu alaikum. Today we are start with chapter number 8, that is thermal stress and thermal strain. My name is Muhammad Arif Aziz from IMAM ABDULRAHMAN bin FAISAL University. Okay, so today we are going to talk about thermal stress and strain. Before proceeding to the problems, we have to have the basic concept about the thermal stress and strain. Thermal stress. Change in temperature causes a material to change its dimension. Okay. When there is a temperature on any material, it will change the dimension of the body. So when the temperature increase, it will expand, and when the temperature decrease, it will be contract. So the basic example of this one, suppose if you have a steel bar, and when we heat it, so there is a change in length and it is expanded. But when the temperature decrease, it will be contract. Now we talk about expansion or contraction due to change in temperature, that is delta T. Okay, so this is a symbol. This is a symbol delta T represented by this whatever you call it, sigma or delta. This is a change in temperature due to thermal expansion. Now, for a member subjected to a constant change in temperature, delta T will be equals to alpha delta T into L, where alpha is a linear coefficient of thermal expansion or contraction of a material of the member. So basically, alpha is a linear coefficient of thermal expansion, and it varies to material. It is different for steel, it is different for aluminum, it is different for copper. Where delta T is change in temperature, which is in degree centigrade, Fahrenheit, or in Kelvin. So what is mean by change in temperature? It is about initial temperature and final temperature. So this is change in temperature. So final minus initial is equal to delta T. Then L. L is the original length of the member. Like suppose L is the length of the member before applying any temperature. So this is the original length of the member. If the change in the temperature varies throughout the length of the member, that is, we will take the integral part. Suppose if the change in temperature vary, suppose this is a rod, a long rod, and this here the temperature difference is different, and here the temperature difference is different. So we will take the integral of that one with respect of x. So delta T is a change in temperature, which will be alpha is a constant coefficient. Delta T is a initial and final temperature. Only length will be represented by x dx, which has a limit of 0 to L. Delta T in case of different alpha and delta T or both along length. Like suppose in this case, there are two cases. This is case number 1. This is case number 2. In this case, length of the member is changing. Here, length of the member is changing. But in that case, in case number 2, length will be remain same. Only alpha and delta T will be changing. So we say that delta T, suppose we have a rod of our length, a rod of length L. Okay. Okay. Now here we have different segments. So each segment have, this is number 1 segment, number 2 segment, number 3 segment. So length alpha and delta T of each member will be different. So it will be represented by alpha n, delta T n, and length n. So n is a number of segment. It may be 1, it may be 2, it may be 3. Okay. So this is segment number. Now that is thermal stress. Now we will talk about thermal strain. Thermal strain are strain that develop when a material is heated or cooled. What is mean by thermal strain? Is what is a strain? Strain is change in length per unit length or change in length over original length. Now, when we talk about thermal, so we say that strain is thermal strain will be equal to, this is thermal strain will be equal to thermal change in length over original length. Okay, this is a derivation based on the above statement. Here we have compatibility equation. In compatibility equation, we have two kind of force, two kind of difference. It is due to internal force and elongation. So that is due to elongation force and due to it is due to elongation for internal forces. It is due to internal forces and it is due to elongation. Okay, and this one is represented by alpha delta T L, and this one is represented by PL over AE. That is force due to or elongation due to or change in length due to stress over strain. If you remember last lecture, in lecture number 6 or 5, I think we discussed about this one. I think 7 lecture we have discussed about this. Now, example number 1. In example number 1, we have a pipe AB. So there is a pipe AB which is rigidly fixed between two turbines. Suppose there are two turbines. This is turbine number 1. This is turbine number 2. So this pipe is fixed between two turbines and the material they used is A36 steel and has an outer diameter of 4 inch and wall thickness of 0.25 inch. So they are giving you the configuration of this turbine which have a outer diameter of 4 inch, that is 4 inch, and wall thickness of 0.25 inch. So suppose this is wall thickness. So basically this thickness is 0.25 inch. Okay. So this is a cross section of a pipe. Okay. So outer diameter is 4 inch and thickness is 0.25 inch. Determine the force the pipe exerts on a turbine when the temperature in the pipe changes from 70 Fahrenheit to 275 Fahrenheit. So this is initial temperature. This is final temperature. First of all, we have to know what are the things given. Okay, then we will proceed accordingly. So for A36 steel, E is 29 into 10 raised to the power 3 KSI. It will be given in the exam or it will be given by the chart. Alpha is 6.6 degree Fahrenheit, 6.6 into 10 raised to the power minus 6 per degree Fahrenheit. This is alpha for steel. Now, what is the delta T? Delta T is equals to initial temperature, final temperature minus initial temperature. So 275 minus 275 minus 70, it will be 205 degree Fahrenheit. Okay. Length of the pipe is 6 feet. So 6 into 12 equals to 72 inch. Why we are keeping it in inch? Because it is in KSI. If it is in KSF, what is mean by KSI? Kip per inch square. If it is in KSF, what is mean by KSF? Kip per foot square. So we will keep it in a foot and we will not change it. So this is in KSI. So this is an inch. we have to make it in a same unit, otherwise it will be a trouble. So see, this is KSI, K per inch square, and this is inch. So you'll see, I'll solve you the problem in the next step, how it works. Anyway, outer diameter of the pipe is 4 inch, which is, suppose this is a pipe, I'm elaborating it, okay? This is a wall thickness. This is a wall thickness, 0.25, and this outer diameter is, so the wall thickness is 0.25, okay, and outer diameter is 4 inch, okay. Now we have to determine internal dia, okay. Internal dia will be, suppose internal dia represented by di, and this is outer dia d naught. So this is 4 inch, we know. Internal dia will be 4 minus wall thickness, 2 times of wall thickness. So actually diameter is represented by this is the area diameter, and this is the area's diameter. So to determine this one, suppose we have to minus this and this. So it will be 4 minus 2 into 0.25. This is the wall thickness, is equal to 3.5 inch. So internal dia will be 3.5 and external dia or outer dia will be 4 inch. Now cross section area of a pipe, because this is a hollow pipe, so that's why we are using 2 areas or 2 diameter. Otherwise, what is the formula of the area? Is equals to pi by 4 d square. So in terms of this one, suppose if we have this pipe is solid, so we say that, okay, pi by 4 into 4 square, okay. So it will be a area, but in our case the pipe is hollow. This is hollow from inside, this is hollow area, so we have to minus outer diameter minus internal diameter. It will be a area, that area, okay, that area, okay, whole area. Now 4 square minus 3.5 square, pi by 4 is equals to this inch square is a cross sectional area of the pipe. Now put everything in the compatibility equation to determine the force. What is our target? What is our target? Our target is the pipe has a rigid fixed support and turbines is made up of 836 steel and has outer diameter of 4 inch. The wall thickness is this. Determine the force. Determine the force the pipe exert on the turbine. Okay. So our target is force. So by putting in the compatibility equation, what is compatibility equation for delta T, which is due to the thermal, this is thermal expansion or contraction. So this is thermal and this is due to the force. Okay, if you remember, what is the formula here for this one? Alpha delta T into L. And what is the formula here? P into L over AE. Okay, so we have given everything. Alpha is given 6.66 10 raised to the power minus 6 per degree Fahrenheit. What is the unit for this one? Per degree Fahrenheit. Okay, this is a unit for alpha. Then 275 minus 70. What is the unit? Degree Fahrenheit. Okay, minus 6 into 12. This is in inch. This is 6 into 12, which is in inch. Okay. Now for this one, PL over E. Okay. For this one, F is unknown. F is unknown, and this is our required. We have to determine F. Okay. So F is unknown. For this one, 6 into 12. The unit will be inch divided by pi by 4 d square into AE. So what is the area? We have calculated the area here, which is 2.95445 inches square. Here they write it again, but okay. What is the unit here? Inch square multiply by E. What is the unit of E? KSI. Huh? What is the unit of kip per inch square? Okay. So when we multiply this one into 2, this is 6.6 into 275 minus 70, it is 205 into 72. So answer will be 0.0974416 inch. Okay, because degree Fahrenheit will be cut. Why I am solving? Because you have a confusion in the solution always in the unit specifically. Now here we have any value in terms of f. So 6 into 12 divided by area, which is we calculated before, 2.9452. 2.9452 divided by 29 exponent 3. So this value will be 5.854 into 10 raised to the power minus 6 F. So in here, the unit will be inch square will be cut by inch square, and here unit will be inch per kip. Okay. So when we take it from here to on the another side of the equal, so it will be 0.097416 inch is equals to 5.854 into 10 raised to the power minus 6 times F kip, inch per kip. Okay, inch per kip. When we take this value from here to another side, so it will be this value 0.097416 divided by 5.854 into 10 to the power minus 6 is equals to F. And the unit, how the unit act, it will be inch divided by into kip per inch. So inch to inch cut, the value will be in kip. So you can calculate that 0.097416 divided by 5.854 exponent minus 6. The answer will be 11640 kip. Okay. The answer will be in kip. So why I am doing this, all these efforts, just to show you that how the unit cut with each other, and we will get the answer in a one term, because there is a confusion, too much confusion in terms of unit specifically. That to avoid that issue, I'm just resolving it. But it's a direct one if you know the unit of force. So you'll write kip. But if you don't know, because sometimes some students make a mistake that kip per inch, kip feet, kip inch, they write it like this, and sometimes they don't write any unit. So please do not avoid to write unit. It has a marks. Example number 2. The C83400 red bar brass rod AB. So there is a rod which is AB, which is made up of brass. Okay, it is made up of brass. And 2014 T6 aluminum rod BC. This is aluminum. At are joined at a collar B. So this is collar, or you can say our joining point B, and fix connected at their ends. This is fix A, this is fix C. If there is no load in the member when when there is no load in the member, when T1 equals to 50 degree Fahrenheit, determine the average normal stress in each member when T2 is 120 degree Fahrenheit. So this is initial temperature, this is final temperature. Also, how far will the core will be displaced? The cross-section area of each member is 1.75 inches square. So this is coefficient of linear expansion for brass. This is linear of coefficient thermal is for aluminum. This is E for brass, and this is E for aluminum. Okay. PSI. This is pound per inch square. Okay. This is pound per inch square. You have to keep in mind the units. Okay. The length of the rod AB is 3 feet and the length of rod BC is 2 feet. Okay. So what we have to determine the average normal stress in each member. Now we have the compatibility equation. You know that we have a compatibility equation in which we have delta T minus delta F is equals to 0. Remember this one? Delta T is alpha del T L and this is PL over AE. Okay, is equals to 0. So here we have make a compatibility equation in which, see, this is for brass rod. See, this is FBR and this is for aluminum rod. Okay, see, FAL. Okay, now we don't know force in brass rod, but we know the length of the brass rod. So everything is in inch. So we keep it in the inch. So 3 feet multiplied by 12, it will be 36 inch. 1.75 is a coefficient, area, which is given. Area here. Okay. The cross-sectional area of each member. So area is 1.75 into 14.6 into 10 to the power 6 PSI. This is E for brass and E for aluminum is 10.6. So this is compatibility equation for brass, and then this one is this is for brass. Now alpha del T into L. This is alpha, which is given, delta T and L. So the brass one has been done. Now for the aluminum, F 2 into 12, this is length, 2 into 12 divided by 1.75 into 10 to the power minus 10 to the power 6 plus 12.8 alpha delta T and length. By solving this equation, we will get the answer in pound, which is force. Why it is in pound? If you remember, our E is in PSI. PSI means pound per inch square. Okay. If it is KSI, it is kip per inch square. If it is PSF, pound per feet square. If it is KSF, it will be kip per feet square. Please remember these units, okay, during the exam. Please. Okay. So by solving this, we got F 17093.4 pounds. Okay, that is our F. So our target was to determine the average normal stress in each member when the temperature is this, and also how far will the collar will be displaced. Okay, so now for normal stress, what is the formula? What is the formula for stress? Stress equals to load per unit area or force per unit area. So we have determined the F, which is in previous slide. F is 17.0934 pound. So we put F over A Here A is the cross-sectional area. We got the stress in the bar. This is stress. Okay, in the bar. About the collar displacement, we have to use the compatibility equation. Then we have thermal due to brass plus this is a negative, and due to temperature thermal this is due to the force, and this is due to the temperature. So we got all the values. So this is will be PL over AE. We got all the values, we put it, and this is alpha del T into L. We got all the values, just put it, and we get the collar displacement at B. So this is the end of chapter number 8. So see you inshallah in the next chapter. Assalamu alaikum.